Accuracy booster formula for finding the cube root of a number using simple calculator. This formula can boost the accuracy to 500,000 times in some cases. Reviewing the cube root of a number method using the simple calculator, the keystrokes is 2 multiply 4 multiply 8 equals. The number here 2248 refers to the number of times you press the square key in the calculator. Check the link in the description box for the explanation of the primary method. The booster formula is the cube root of x, the final one, is equal to the initial cube root multiply by the quantity, the cube root of the initial raised to the 1 over 65536 power minus 1 quantity multiplied by the ratio of 65536 divided by 65535, then plus 1 again. And this whole quantity multiplied to the initial cube root that you find with the 2248 method. X, the cube root of x final is the final answer after the boost. Xi is the initial answer from the 2248 method. 1 over 65536 power is obtained by pressing the square root key 16 times. The procedure: first, obtain the cube root initial through the 2248 method explained in the previous video. Number 2, store x cube root initial in the memory plus bank. Number 3, press square key 16 times, then minus 1, then equal key. Number 4, press multiply key and input the number 65536. Number 5, press divide key and input 65535. Number 6, press plus key and input 1. Press multiply key, then memory recall key. Press equal key, and that's the answer. That's x to the 1/3, the final x to the 1/3. If you look at the formula, so this is the formula. Example, find the cube root of 3 final. First, obtain the initial cube root of 3 using the 2248 method. Note, you can use memory plus instead of the equals key. See, you can see from the formula how you're able to proceed with the procedure. The first thing is input this value from xi to the 1/3 in the memory plus bank. Then after that, this xi, the cube root of xi, you raise it to 1 over 65536 power. That's by pressing square root key 16 times. Then you minus 1. Then that quantity you multiply by the ratio of 65536 divided by 65535. After you get the product, these two quantity, you plus back 1 again. And that whole quantity is now multiplied back to the memory recall. The memory plus that was stored. So you retrieve it back by multiplying the XMR, memory recall. And the product of that is the answer. Example, find the cube root of 3. And this is for the initial value. Input 3, press square key twice, multiply, twice again, multiply, 4 times, multiply, 8 times. And then you store it in the memory plus. And this number is the initial cube root of 3. And if you want to boost the accuracy of this is what you do. You press square root of key 16 times. Minus 1, multiply by 65536, divide by 65535, plus 1 again, and then multiply by the memory recall. And now this is the answer. That's the very accurate cube root of 3. The result. This is the initial cube root of 3, and this is the value. This is the true value from a scientific calculator, and this is the value that we obtain, the final cube root value. And look at the decimal. It is accurate up to here. And the error for the initial value is 0.000558%. For the final cube root, this is the error. 0.000000006754%. And the ratio of error is 82,000 times. Explanation for the booster formula. The cube root of x initial is obtained by the 2248 method, which translate mathematically as cube root of x initial is approximately equal to x raised to the 21845 over 65536. That is the power. In which, in decimal form, it's x raised to the 0.333328244707, which is very close to 1/3, in which 1/3 is 0.33333333. So getting the ratio of 0.33333 divided by this one, 0.333328244707, will get you a ratio is 1.0000152591. So therefore, cube root of x final is approximately equal to, this 1 is x cubed initial, right? That's 1. And other one is x cubed initial raised to the 0.0000152591. So this multiply by that will get you 1 point, this one. But the cube root of initial of 0.0000152591 is equal to approximately to the xi raised to the 1 over 65535 power. How do we evaluate this x raised to the 1 over 65535 power? We know we can get x raised to the 1 over 65536. That's by pressing the square root of key 16 times after the x initial, cube root x initial is inputted. I discovered an approximation of this x raised to the 1 over 65535 is approximately equal to x raised to the 1 over 65536 minus 1 multiplied by the ratio of the 65536 divided by 65535. Then you plus back to 1 again. Refer to my video about special cases of evaluating exponential numbers in the link. So cube root of x final is equal to cube root of x initial multiplied by cube root of x initial raised to the 1 over 65535. So substituting, then you have this formula. Cube root of x final is equal to x initial, cube root x initial multiplied by quantity, this one, the x initial, cube root x initial raised to the 1 over 65536. That's pressing 16 times of this value. You minus 1, then you multiply that by the ratio of the two different exponents, 65536 divided by 65535, then plus 1 back again, and this whole quantity multiplied back to this cube root of x initial. Note that this formula also works for the 5th root and the 17th root approximation using a simple calculator. And the 5th root is, the keystroke is 3148, and the 17th root is 5128. Check the link to the videos.